review worksheet number 4. We're going to find the coordinates by completing the square. So the first thing we have to do on these problems is that we have to get out the factor that would make the coefficient 1. So we're going to pull out a -2 here, and we're just taking a -2 out. So we're going to have x squared, and we're going to have to change it to plus 4x, so that -2 times 4x is still -8x. And then we're going to add something. We're going to put the -1 there on the back end, and then we're going to think about the back blank in just a second. I can put minus blank right now. We'll talk about that in a second. So here's the deal. We need this middle part to be a perfect square trinomial. We've talked about this in class and why it's important for that, for vertex form. But the process of doing this is pretty simple and procedural. Take half of 4, take half of this term, which is 2, square it, which is 4, and that's what goes in this blank. The only thing you need to be careful of right here is that we really are subtracting 8. Okay? -2 times 4 is really a -8. So we kind of made this up. We subtracted 8. So on the back end, we have to add 8 so that we don't change the value of the problem. Subtracting 8 and adding 8 is the exact same thing. So here we go. Now we have the function. We have an a value here of -2. We have a factored trinomial into x plus 2 quantity squared. And then we have plus 7 on the back end. Okay? So that was the procedure for completing the square. And now we can answer some questions. I'm going to ask you for the axis of symmetry. The axis of symmetry is going to be x equals -2. Because what we do is we look in here and we know that we're going to go left 2, up 7. So the axis of symmetry here is the vertical line, x equals -2. Be very careful that you give that entire line when you answer that question. The vertex is actually -2, 7. And we know that we go left 2, up 7. So up 1, 2, 3, 4, 5, 6, 7. That's the top of this graph shown right there. All right, and then what do we do from here is we are going to use our a value to complete the graph. So we're going to go left 1, down 2, right 1, down 2. And then we could sketch it, or you could go over 2. Normally we go 1, 2, 3, 4. Now we're going to go 5, 6, 7, 8. We're going to go twice as far as we normally do. So this is going to be a parabola. I'm trying to sketch it. It's kind of tricky here with this pad, but that's where we're at. So vertex form, just so we're all clear. If the question was asked for vertex form, this is vertex form right there. This is the vertex right here, and this is the axis of symmetry. So that all fits together for you. Okay, next method would be find opposite of b over 2a. Okay, so in the middle here, we're going to start with, do this in blue here, we're going to start with the formula x equals opposite of b over 2a. You're starting with finding that axis of symmetry. So the opposite of b, -12 over 2 times 2a, and that would be -12 over 4, so that's just going to be a -3. So the axis of symmetry is x equals -3. So if I go on my graph left 1, 2, 3 and make a vertical dashed line, that's the axis of symmetry. All right, how do I find the vertex? Well, I know that the vertex will be somewhere on that line. So again, quite procedural here. We're going to evaluate the function when x is -3. So we have 2 times -3 squared plus 12 times -3 and then plus 16. So just slow down in your order of operations. 9 times 2 is 18 minus 36 plus 16. So what we're getting here is -18 plus 2. I'm sorry, plus 16 gives me a -2. So that means the vertex is -3, -2. So that's going to be right here. And again, we look at our a value of 2. That tells me the graph is going to go up. And again, it has a vertical stretch factor of 2. Over 2, up 1, 2, 3, 4 normally. 5, 6, 7, 8 for this one, because it's twice as far as we normally do. Sorry about the sketch. Got a little sketchy there. Okay, next. Number 3. So on this one, we can use either one we want. All right, so you can get with your comfy zone. I'll show you mine first. I like this one. I think it's kind of fast. X equals the opposite of b over 2 times negative 1. Oh, I just thought of something. Let me pull up this red right here. For the last problem, I will ask you to put that into vertex form. So to take that step from our given information, you just got to know the a value at the beginning, which is 2, and then you got to know the vertex. So this would be x minus h, so plus 3 quantity squared, the h value of the vertex and the k value of the vertex. So then we have minus 2 on the back end. So that's vertex form. So on this one, sorry, back to this one now. Opposite of b over 2a, that'd be negative 6 over negative 2, which is a positive 3. So we know our vertex is going to be along this axis of symmetry. And to find that vertex, I have to do f of 3. So that's really negative 1 times 3 squared plus 6 times 3, and then minus 8. So this is going to be the opposite of 9, plus 18 minus 8. So we have ourselves positive 9 minus 8, or a 1. So the vertex is going to be right there. And then the vertex form, like we just discussed, would be a value of negative 1, and then x minus 3, because we're going to go right 3, and we're going to go up 1. And then the vertex for this problem will be 3, 1. Right, 3 up 1. Okay, and then we use our a value, which is, this one's actually going to open down, and there's no stretch. So over 1, down 1, over 1, down 1, over 2, down 1, 2, 3, 4, and it's symmetrical. So that's a pretty decent sketch for this graph. Okay, so we're obviously going to have a maximum point there when it opens downward. Throw it in green real quick. Give you another practice with completing the square method. I would want to take a negative 1 out. And then on the inside, I have an x squared and then minus 6x, because I got to take the negative 1 out of this positive. I'm going to have plus something, and then minus 8 on the back end, minus something on the back end. Okay, so this is actually going to be negative 1, and then half of 6 is 3. 3 squared is 9, so I put a 9. I need to be careful, because with this negative 1 here, I actually subtracted 9. So on the tail end here, I have to add 9. And then on the inside here, I'm going to have x minus 3 quantity squared plus 1. And then there you can see I'm right. I mean, that's it. That's vertex form, just found using a different method there. Okay, moving on to the second sheet here. Let me go through this. Determine the quadratic form. All right, so on this one here, determine the quadratic function. You got yourself a vertex. So right away, you know you've got h and you've got k. And then they give you another point, which we've just been calling x and f of x, or x and y, same thing. But just know vertex form is right here. F of x equals a times x minus h quantity squared plus k. Well, here's the deal. If I knew my a, my h, and my k, I'd be done. But I don't know the a. So what we've been talking about is you got to find the a value first. Step 1, find the a value. Then we just answer the question. Well, f of x is actually the negative 2. Because we know that we have any ordered pair on the graph. And that's what we've discussed. Leave the a the same. The x is the 6 from the ordered pair. And then we go to the vertex. So minus 4 quantity squared and then plus 1. Okay, again, order of operations is important. A times 2 squared is 4. That's really just 4a there. Okay, this all just says 4a. Take that slowly and realize that. And then you add 1. Subtract 1 from both sides. We have negative 3 equal to 4a. And then divide both sides by 4. You're going to see your a value is negative 3/4. All right, so tie this up with a bow. Put it in vertex form. F of x is equal to, now I know my a value is negative 3/4. And then my hk, so x minus, where's that? Right there. So x minus 4 quantity squared and then plus 1. And that's the answer to that one. Determine without graphing if that has a max or min. Well, I'll tell you right now, it takes about a second to see that this has a negative a value. So it's going to open downward. Okay, this one's going to open down, meaning we're going to have a maximum value there. So this will have a maximum value. All right, so that's the first part. And then find the value. We're trying to stress this as much as we can. The value of a function is always the y value. Okay, you got to get that down. The y value, sorry. is the function's value. So when we do this, we want to find the vertex. The vertex will be the ordered pair that represents the maximum there. So to do that, we've been talking about finding that vertex is going to be negative b over 2a, and then you find the function evaluated at negative b over 2a. Well, okay, so we start with x equals opposite of b, so that's 40, over 2 times a, so that's actually negative 10. So we're going to get a negative 4. But negative 4 is just the x value of the ordered pair. So this will have negative 4, and then I got to figure out the y value. And that's the answer to the problem. So looking at this, we have of negative 4. So that's going to be negative 5 times negative 4 squared minus 40 times, negative 4 minus 80. So if we work through this, what do we got? We got negative 4 is 16. We're going to have a negative 80. 16 times 5, negative 5 times 16. And then we have, reading my own writing there, plus 40 times 4. So that's 160. And then we have minus 80. So what is this coming out to? Negative 80. That's going to be at 80 minus 80. So this one's actually coming out to 0. Okay, so what's the answer to this problem? It's actually 0. Now if we're putting all of this together, this is actually going to be the ordered pair negative 4, 0. So if you think about this a little bit, see if this makes sense, the graph would kind of look like that. Like the origin would be here and negative 4, 0 would be the maximum point for that graph. Okay, so hopefully that helped. The answer is 0. Be clear of that. Okay, now look at this one. A rocket is launched from the ground with initial velocity. Okay, so here's what's great. They tell you this information, but don't make these harder than they have to be. The height of the rocket, t seconds, so that just made us, our t value is really x, and they give you the formula. So I really want you to understand these problems, but these all come back to just knowing the basics of a parabola. This is going to be a parabola, a quadratic function that opens downward. Okay, so let's think about this right now. How high is the rocket after 4 seconds? At what time does it reach its maximum height? At what time? There it is, at what time? Well, we know that time is in seconds, so they're asking for the x value of the maximum. And what is the maximum height? Well, that's the highest it's going to reach. That's the h value, which we obviously know is the same thing as, that's the same as the y value there. So B and C are just finding the maximum. And I'm actually going to start there, and then we'll talk about part A. But to find a maximum, I hope we're getting this down, that's going to be opposite of B over 2A. Okay, so opposite of B over 2A, so on this problem would be negative 136 all over 2A. So what's that, negative 32? So this is going to be 136 over 32. Okay, so a positive value. And then what does that come out to? Let's see if that comes out really nice. 136. I was trying to get this on my screen. I don't know if I did that. Let me show you that. Divided by, whoops, wrong thing, sorry. 136 divided by 32. 4.25. So it didn't come out crazy, but it came out to 4.25 for an x value, 4 1/4. So what's that mean? That means it's going to take 4.25 seconds at its maximum height. So this maximum height is 4.25 seconds after the launch. Well, what's the height? Okay, so now what are we going to do? We're going to actually evaluate the function at 4.25. So that's going to be negative 16 times 4.25 quantity squared plus 136. And you guys, I think, are starting to understand how to just kind of pop this back in there. Okay, so what's this going to be? This is going to be, let's pull up that calculator. Let's take the 4.25 squared and let's multiply that by 16. Okay, so it's 289, which we know is actually negative 289. And then we're going to add that to 4.25. Just showing you the calculations here. So you know, like, what am I using? I'm using a non-graphing calculator. I'm just doing some calculations. So that's 578. So we've got 578. Okay, so when we do the math here, we have 578, and we want to subtract 289 from that. or negative 289 plus 578, which is obviously giving us, did I just do that right? I'm sorry. I don't know if I said 289 or 298. Just let me make sure, since I am on video here. 578 minus 289. I just don't know if I plugged that all in correctly. Okay, I did. So 289. So that is the answer. That's the maximum height reached. Well, what is height in? You want to be careful here. Feet. Okay, so 289 feet. So that's the y value up there. So hopefully you know right now, if we're going to go back and do part A here, I'll do that in red so it's different. I'm hoping you know that the answer to A is going to be smaller than 289. 289 is the highest it reaches after 4.25 seconds. So an x value of 4 or 4 seconds is going to be less than 4. Somewhere in here, the height is going to be lower. So all you have to do there is realize you were given the x value. So all you do is you take h and you evaluate it. I said f before, same thing as h. Okay, here's our function, the height, and you evaluate it at 4. So now all I'm doing is negative 16 times 4 squared plus 136 and then times 4. The x value is 4. Okay? So what are we getting here? We're going to get negative 16 times 16, so negative 256. All right? And this is 4 times 100, 400. And then what is that? 30, 72, 144. So plus 544. And then we're going to have 544 minus 256. I'm sorry if I do that too fast sometimes. So let me just show you again on the calc what I would do. 16 times 16 we know is 256, right? And then we have 136 times 4. That's off to the side here. This is nice. So if I have 544 and I subtract 256 from that, 544 and I subtract 256 from that, eventually, touchy, we get 288. So if you look at this, okay, it's 288. So how high is it? It is less than 289, barely, but it's 288 feet. Okay, so what was this? This was applying an application problem, but I did not pick up a graphing calculator. I don't need a graphing calculator. I just need the background knowledge of what's going on with quadratics. I hope this helped.